questions, you can ask me later. All right, a contestant in a winter sporting event pushes a 45 kg block of ice across a frozen lake as shown below. Calculate the minimum force F he must exert to get the block moving. What is its acceleration once it starts to move, if the force is maintained? Okay, so if it was a frictionless surface, the force you would need is almost zero to get it moving. So in this problem, obviously it's not a frictionless surface. So you're pushing a block of ice on a frozen lake. So what we want is static coefficient of friction for ice on ice and mu k for ice on ice. Can somebody look that up in your book?
Ice for static is 0.1. Kinetic is 0.03.
Okay. All right, so now let's set up the equations. Okay, so the maximum static friction force is mu s times the normal force. Okay, and here is F. Oops, that's 25 degrees. So here is F. Here is F sine theta. Okay, and that's this component is F cosine 25. Oh, this got messy. Okay, let me redo the diagram. Here is F. This is F cosine 25. Here's the maximum static friction force. Okay, so we are setting it up where he is applying a force F that's just enough to barely push it. Okay, and so get it started. Okay, and you apply a force greater than that, and it should accelerate. Okay, so and then the other forces are mg and the normal force on the object. Okay, so let's look at all the y component of the forces. Y component of the forces is, and again our axis is set up like this. So the normal force is positive minus mg and minus f sine 25, and that's 0. So the normal force is equal to mg plus f sine 25. So what we are saying is, when you push down on an object, the normal force is greater than the weight. Okay, so if you were pushing horizontally, then the normal force would just be equal to the weight of the block. Okay, so that's what this is telling you. Let's look at the x component of the force. The x component of the forces are, so you can see that this is f cosine 25 minus fs max. Okay, those are the only two forces acting on it. And the object is barely about to start, so the acceleration of the object is 0. Okay, f cosine 25 is fs max, which is mu s times the normal force, which is mu s times The normal force is mg plus F sine 25. Okay. So okay, so F is mu s times okay, that is the force that you need to apply to get the block moving. Okay, and if this is positive, then it has a solution. This and then you could move the block. If mu s was too large and you're pushing down on it, this could get negative, and then you couldn't move the block. Okay. All right. So and of course, if this angle got larger as well, you couldn't move the block. Okay. And you can see that from there, as theta gets larger, cosine of theta gets smaller. And okay, let me write it like so. Mu s times mg divided by cosine theta minus mu s sine theta. And as theta increases, this is getting smaller, this is getting bigger, this is getting to be negative, and you won't be able to push the block. Okay. All right, so now let's, so F is, let's calculate the force, mu s times mg divided by cosine theta minus mu s sine theta. 0.1 times, what is the mass of the block? So the force you need is to get it moving as this. It's 51 newtons. Okay, so a force of 51 newtons will get the block started. Okay, once the block starts, the coefficient of friction decreases. The kinetic coefficient of friction is smaller, so now the block will start accelerating. Okay, so now let's look at the x component of the motion once the block starts moving. Now the friction force is the kinetic friction force, and the x component is F cosine theta. F cosine theta minus Fk, the friction force is mass times acceleration. Okay. And the normal force is mu k. The normal force is there's the normal force mg F sine 25. I know I'm going a little fast, but as you can see, I have 5% battery left. Okay, so this is F is 51 newtons. cosine 25 minus 0.03, and that's the kinetic coefficient of friction. Okay, mg is 45 times 9.8 plus 51 times sine 25 divided by 45. And this works out to 0.72 meters per second square. Okay, so that's the acceleration of the block. Was there anything else to this problem? No. So that ends that problem. What problem number is it?